Hello and welcome, ladies and gentlemen, to Kerbal Aeronautics and Space Administration's Real Progression Light, a realistic playthrough of Kerbal Space Program's career, with Real Solar System, Realism Overhaul, and Real Progression Light.
Alright, launching in 3, 2, 1.
In this series, I attempt to play through the Kerbal Space Program's career with all of the very difficulty-adding mods that I can get, as well as a few parts mods that make my life a lot easier, and attempt to do something at least in the range of realism, because difficulty is fun.
Oh, that's the beach.
Yes, it's a beach in Alaska.
It's not desert, it's sand. Well, I guess sand in the desert.
Very difficult to tell with these textures of the planet, but yes, there is sand in the desert. That is the thing that exists and is quite common. Anyways, in the last episode, we did a bit of a review of the entire series, so if you're new to the series, you should go check that out. I annotated in the description. Kind of went a bit loopy on the change of format. There was a change in the format.
Probably go ahead and turn on FAR. Yeah, we are in the high dynamic pressure range. We are almost through the troposphere. Probably a little bit towards the top of the troposphere, we will go back to nominal.
Okay, did I already mention that this is an Athena 1, which is our standardized launch system, and it is carrying a high-resolution mapping satellite?
And we have officially entered the stratosphere.
We are going all the way up to 3.5 by 3.5 megameters with this satellite.
Let's go ahead and switch this to orbit. See, this is exactly why it's best to launch from the poles. We are currently traveling east, because the surface of the planet is
moving east, is what I meant to continue to say, but then I got busy paying attention to other things, because hashtag rocket science. Hashtag not rocket science. Yeah, a lot of the complexity of rocket science, but still not quite rocket science.
Alright, we have first stage burnout. Second stage is away.
So this is a fairly recently built standardized launch system. After getting tired of spending way too much time on building launch systems,
RCS is active,
and then having them fail in minor ways, I decided to standardize, and it has made my space program go by so much easier. Thank you, subassembly loader. I like the lights. I'm not too keen on the color. Keen.
Second stage is lit.
What am I, in the 70s? Keen. Haha. Okay, it is time for a bit of history. The very first picture of Earth from, quote, space was taken on a suborbital flight of a V-2 rocket in 1946 from an altitude of 105 kilometers, which we have already passed. The first thing to be in orbit, don't really want to call it a satellite because Explorer was small, and the first thing in orbit was Explorer 6 to take a picture of the Earth in 1959. So not too long after that, about 11, 12, 13 maybe years, Landsat, that organization that I'm sure you've heard of, was founded. I think it was more kind of reshuffled and reorganized into an official organization that had a primary goal of observing the planet and its many changes. But anyways, that was started in 1972. And its first satellite launched on a Delta 900 rocket from Vandenberg to a 900 by 917 kilometer orbit at 99 degrees inclination. So just a little bit off polar, as I'm sure it's very, very difficult and delta V consuming to get a perfect full orbit. And also I don't think that there's too much of interest for Earth absorbing satellites at the exact poles of the planet. There's not much up there at all. I guess now it's maybe a little bit interesting, with a little bit more interesting with the northern ice melting almost completely in the summer. But anyways, it was a modified Nimbus 4 meteorological try this again. Meteorological satellite, and it was equipped with a video camera tube, which was kind of like a cathode ray tube. If you were alive 20 years ago and you had one of those, if you had a TV pretty much, then most likely you had a cathode ray tube. They're big. I still have a CRT monitor, and that's what was used to actually capture image before CCDs were invented in the 1980s. But anyways, even with the limiting technology at the time, it was able to capture images at 480p. 480 resolution of 485 lines, I think it was. Maybe it took video. I think it did, like 30 seconds of video or something. But anyways, it was a it also had a multispectral scanner for height mapping and a data collection system used for relay. It surprisingly, it discovered an uninhabited island 20 kilometers off of the east coast of Canada, and it was subsequently named Landsat Island. So that's kind of nice. First satellite into orbit, doing some first constant observations of the planet, and to have a milestone like that. But anyways, that's something I say a lot, and I should probably cut back on it. Yes.
We're going to make a slight course correction here. Or I should say attitude adjustment.
Adjust your attitude.
It's going to go up to about 13 degrees. And slightly west. Just to bring that prograde marker into a line with the poles.
Less delta V consuming. Moving on in our bit of a history lesson here. Although this one is less of history lesson, Landsat 8 was Landsat's latest satellite to go into orbit. It launched February 11th, 2013 on an Atlas V from Vandenberg. Vandenberg Air Force Base, in case you didn't know, is on the west coast of the United States in California, sunny California. And its destination was a 708 by 710 kilometer orbit at 98 degrees on the day-night terminator. So it's always has sun, which is good for maintaining electricity.
Okay, maybe we don't have to be at 15. Let's go to about 7. And we have second stage burnout. And third stage is away. Third stage is active. Let's go ahead and stick this at about 5 degrees.
Okay, Landsat 8 is the subject that we were talking about. Oh, that's what I was going to say. This satellite that you're viewing now, the Athena 1A, is very customizable. I can put something, as long as it doesn't weigh too much, I can put something into orbit around the Earth at pretty much any distance, and even go to the moon. Again, it can't weigh too much. Anything, I think, is about 1 ton is the max that I can put in a geosynchronous orbit. Because you get up into the range of having a bit of anxiety and not having enough thrust-to-weight ratio and not being able to get off the ground is a problem. And then also, during your ascent, you want a decent thrust-to-weight ratio as well. So when the tank gets really heavy and you got a bunch of fuel, can't quite make it. But back to Landsat 8, its main mission was a medium resolution. I abbreviated in my texts, my notepad. Medium resolution multispectral images of seasonal changes on land, which is quite a novel thing for a satellite to do. There was one in here that I forgot to actually mark that has a resolution of 15 meters, but for all intents and purposes, let's just say that all of these have a 30-meter resolution, and I will list them oft. A little bit of an extra T on the end there. I will list them off right after Old Me talks to you.
Alright, we've kind of drifted up to 10 degrees, and our time to apoapsis is increasing, so we'll go ahead and drop that back down to 5. Maybe get a little bit over towards north. We still have a slight adjustment to make, but it's really close.
But wait, there's more. Any second now. Tick tock, tick tock. Hello.
Maybe a little bit below 5 here. Let's go to 2.5. We want our time to apoapsis to decrease. And we must be close to circularizing. So we are below horizon, it's still increasing. So let's go down to -7.
Nope, still more.
Okay, -15. There we go. That's a little bit too much. Let's go up to -10.
Redundant speaking. I guess it's important for the people that are new to this game or are unsure how to manipulate their apoapsis height.
And it looks like our
I said height.
brigade marker is almost perfectly aligned with north. I'm not sure if that's because of where we are in the orbit or if our orbit actually is perfectly polar. I can always make a inclination change later.
Perfectly polar isn't all that it's cracked up to be.
Alright, let's get back down to -15 because our time to apoapsis was starting to increase again.
Yeah, that's a thing. If your apoapsis is increasing and you don't want it to, burn towards the planet.
And we are a little bit short. We're going to 22 kilometers. Just going to make sure that...
Or you can do as I'm doing right now and just wait until you're actually at your apoapsis, which we are 42 seconds away from currently.
We do have propulsion method, we do. Okay, so go ahead and stage.
Am I going to get time to list off these things that it observes?
Just by staging it got us into orbit.
Did I say observes?
Or it changed the camera, I should say. Whoa, let's turn off RCS.
I think I said observes.
That reaction wheel. Start our scan.
I meant observes. Observes.
And extend our panels.
The observes. Observes. Okay, I will try to list those off as fast as possible right after this.
I just lost connection, so we'll go out to map view and switch to Geocom 1.
In order of length of the wave: aerosol, panchromatic, blue, green, red, near infrared, cirrus, 2 short infrared, and 2 long infrared. Did that go by fast enough, is the question.
We are reaching our memory limit. The more craft that I load, the more it fills up. So I'm probably going to have to restart here pretty soon.
Yes, that's one thing. I have deleted a whole bunch of parts from the mods that I've installed because they're redundant, but even still, I have problems with memory limit.
Right. Okay, we are connected.
Shortcut there.
Whoa.
I just got rid of a little bit of stuff where I was messing around with the satellites that you didn't really need to see. Anyways, if you heard me say cirrus, that is actually a type of cloud. And if you've ever looked up on like maybe a windy day, or it's sunny out, and you see like these light kind of wispy, very light type of clouds, that's what those are. And it is important to monitor those, because I believe they're in upper atmosphere and suggest things about lower atmosphere.
Oh, we've already passed our apoapsis, so we should be burning above the horizon.
I'm a bit scared I've ran out of things to talk about in my notepad. Ask me questions and comments.
Probably extend this. Take take a look at our electricity.
I've went ahead and gathered some of the Earth-observing satellites that are currently in orbit. I was going to do the complete list, but that is very, very long. So I put together a summary of some of the most interesting facts about all of the commercially available, commercially used satellites that take pictures of the planet. And I will endeavor to list them all off before the end of the episode. Don't have very long, and there's quite a lot of information here, so before we get started, my notepad is telling me to briefly define wavelength, which is not something that I'm entirely sure I briefly do. So we refer to this thing called visible light, and that is red, green, and blue, the three colors that we can see. Below blue there's ultraviolet, and maybe you've heard about those rays from the sun that can be damaging to your skin because they have a shorter wavelength and therefore a lot more energy. And then above red, you get blue is the smaller, and then green is the middle, and then red is at the top. The above red is infrared, which is a measurement of heat. It's infrared radiation. How am I doing? These the wavelengths of visible light are the wave pattern in a length is between 390, which is blue, and 700 that we can actually see, but there's plenty of information both above and below visible light that we can with satellites, or we can with cameras, take a picture and then map those things to like blue or green or stuff like that, so we can actually see in infrared with some modifications to the image. I think that might have described it. If I'm sure I didn't do nearly as good a job as or as thorough a job as Space-Time Cosmos, A Space-Time Odyssey, which is currently on Netflix. I believe it's the 9th episode that talks about wavelengths and light, and I will link that in the description. Moving on, another thing to be defined is resolution. So in any digital image that you take, it will have a resolution of lines vertical by horizontal, and if you multiply these together you get the amount of pixels that are in the image, and that is per pixel is how you measure resolution. So inch per pixel, or meter per pixel, or centimeter per pixel is what I will be talking about when I say resolution, talking about satellites that observe Earth. Aha. Okay, last thing is swath, or swatch. Swatch. I believe swatch is the color picker in like Photoshop, or like you have a swatch pad. Swath is a piece of land, a wide swath of field, and I will be referring to the swath as the width, and probably going to leave out the height. For the most part it's usually the same as the width, but sometimes it differs, of the amount of area which the satellite can view, or which the camera on the satellite can view. So moving right along to our first satellite system, this is a constellation of disaster monitoring, or it is the disaster monitoring constellation. it was built it is operated by Surrey Satellite Tech Limited for Algeria, Nigeria, Turkey, and China. And it monitored the effects of the Indian Ocean tsunami in 2004 and Hurricane Katrina in 2005. Moving on to the Pleiades constellation. It is a French-Italian optical and radar satellite constellation. It has a 50 centimeter panchromatic resolution, which is kind of a limited, it's like the monochrome panchromatic. It's multitudes of monochrome. But basically, for the most part, black and white. And then it has a 2 meter, which is 6.5 feet, multispectral, which is, of course, the red, green, and blue, and probably near infrared, because that is quite a common one in optics. Or when you're referring to multispectral, it might get a little bit of ultraviolet, but not very much. Both the ultraviolet and the infrared spectrums are quite big. And that has a 20 kilometer swath. So it can see 20 kilometer segments. Next is the Earth Resources Observation Satellite, and it is run by for the Israeli government by an Israeli company called ImageSat International, and it is primarily tasked with monitoring Iran's developing nuclear program with an optical camera. So it's within the red, green, blue spectrum is its main use, and it has a resolution of 70 centimeters. So it's pretty good. It's definitely kind of more towards the spy satellite of things. Fromosat, I think, is a Chinese satellite, and it's run by the National Space Organization. There wasn't too much information that I could find on this. I believe it's for public awareness, or maybe just data gathering, possibly spatial mapping, like Google Maps and stuff like that. Not Google Maps, because it's China, and I think Google does operate to a limited extent in China, but not that much. And it's high-resolution photographic. It was launched from Vandenberg on a Minotaur C back in 2004. Ichronos, I think that's the correct way of saying that, is a Lockheed Martin satellite. So for those of you who don't know, Lockheed Martin is a US-based defense and space company, and it was the first Department of Commerce approved optical satellite, optical high-resolution optical images of the United States. So yes, that's it's multispectral, which ultraviolet and infrared, which are parts of it at least, and then mostly optical, and a swath of 11 kilometers. There's QuickBird 2, which is a US-based company called Digital Globe. It's multispectral. Multispectral with a resolution of 2.4 meters, and panchromatic with a resolution of 60 centimeters and a swath of 18 kilometers. It has 128 gigabytes on board, and it was launched in 2001, so that's quite an achievement for, that's a decent amount of memory for 2001. I remember back then 40 gigabyte hard drives were quite a lot at the time. On to Red Eyes Constellation, which is a German company that has been renamed Blackbridge. Since 1996, they have been doing agricultural, forestry, security and emergency, environment, and spatial solutions, stuff like mapping, navigation, and 3D modeling for things like video games, and I'm sure maybe a little bit of 3D modeling for maps and stuff. They also do energy and infrastructure energy. From blue to infrared, the resolution is about 5 meters, and they cover a swath of 77 kilometers. So they have a really decent camera on those satellites that they have in the constellation. Spot is run by a French company, Spot Image, which does climatography and oceanography, as well as studying natural phenomena and human activities. It does panchromatic and color at a resolution of 1.5 meters, and multispectral at 6 meters over a swath of 60 kilometers. TerraSAR X is a joint German Aerospace Center and Austrian satellite. It is for topographic and land use mapping. It also does some surface movement and radar. It does radar mapping in the it does radar mapping in the X-ray at 31 millimeters. 31 millimeter is the wavelength that it bounces off the surface. Yes, it's mostly for height maps. It has a variable resolution because it is radar mapping rather than optical. So over a swath of 10 kilometers, it can map at a resolution of 1 meter. 30 kilometers would be 3 meters, and 100 kilometers at 18 meters. But anyways, moving on to the constellation of small satellites for the Mediterranean Basin Observation, or quite a long name, or Cosmo SkyMed, is Italy's Ministry of Research and Ministry of Defense's joint venture that has also sold some of its imagery for commercial use. So yeah, there's a bunch of complexity in between, like the research department and the military and the commercial use of it. But and because of that, the satellite itself and the modes and types and things that it can do is quite complicated. But basically, it has 2 modes for 3 types of scanning. And the first one is Spotlight, which has 2 modes. The one of them we don't really have any information about because that is primarily for military use and not available for public information. But the research side of that takes in 10 meter swaths, has a resolution of 1 meter. And then another type of scanning is strip mapping, which it does 3 and 5 meter resolutions. I'm not really sure what that means. Maybe it's based on height or something, but that's what I discovered. So I'm just going to assume that it's 5 meters. So it has a 5 meter resolution at 40 kilometer swath, and then another mode where it has in a 30 kilometer swath 15 meter resolution. I'm assuming that these are different wavelengths, or possibly just a different type One's high energy, high electricity, very draining, and then the other is not so much, or maybe it's dependent upon data storage, because I'm sure that's the thing that needs to be thought of. These things operate, they usually take pictures or short amounts of video and then store them on like a hard drive or a solid state device or something, and then slowly transmit the data to a ground station. So that needs to be kind of kept in mind, how much data, because the bandwidth to the ground station is a lot less than the bandwidth to the memory, or what the resolution of the pictures could be. The final mode is, or the final type, I should say, is ScanSAR. Not really sure what this means. I didn't take the time to Google it. This list is getting kind of long. It has 30-meter resolution at 100 kilometers of swath of land. 100 kilometer swath of land, or 100-meter resolution at 200 kilometers, at a 200 kilometer swath of land. So basically, you can kind of think of this as a zoom level-ish. I mean, it's different types of configurations, and I'm sure it's different wavelengths, but if imagine yourself in space floating around in circles, and you had a camera and you zoomed in really far, you would have greater resolution but a smaller part of land, and then zoom out would be exactly the opposite. Worldview 1 and 2 is for the U.S. National Geospatial Intelligence Agency, which is an agency I didn't know existed until I looked this up, and it operates under the Department of Defense. So no data at all is available for either of these satellites. Not sure what they were doing listed under commercial satellites, but yeah, built by Ball Aerospace was the only information that I was able to obtain about that. And the final, and probably the best, is GeoEye, which is a US-based company, General Dynamics C4 Systems, and that is a Google exclusive satellite with a resolution down to 41 centimeters, and everything that's higher resolution than that goes straight to the NGA, which is the National Geospatial Intelligence Agency, and it does swaths of land of 15 kilometers. So super zoom. Whew, I talked for a long time, and it is time to end this episode. Thank you for joining me, and I promise next time I'll be a little bit more precise and not take quite as much time. Make sure to like this video if you did in fact like it. I always enjoy reading your comments, so if you have something to add to the video, or maybe something that I forgot, or possibly a critique, or some type of feedback, I always appreciate having any type of feedback at all whatsoever to help me improve. And don't forget to subscribe if this is the first time on my channel and you would like to see more of my content. So my notepad is telling me to roll a clip from the next episode, and I'm sure that's already been rolling, so you're welcome, and I will hopefully get that done soon.
It's hard to know where the equator is. It's probably right about there. What is that doing? I've never seen that before. Okay. Nope. No. No.